Okay, let us discuss problem 2.39. So this is something related to adiabatic compression. Question says 1 mole of oxygen. So number of mole is given. That is 1 mole. 1 mole of oxygen initially have at temperature T0. So temperature is also given. So initial temperature is T0. Is adiabatically compressed to increase its pressure by eta times. So let us say initial pressure was P0. So T0 is the initial temperature, P0 is the initial pressure. Finally, after compression, the pressure becomes, so let us say P2 becomes, so this is P1, this is T1. After compression, P2 becomes eta times P0. This is given in the question. Find the gas temperature after the compression. So you have to find, first part of the question says find T2. There is a temperature after the compression and gamma is given. So diatomic gas you have, so gamma is given to you. So gamma, that is Cp by Cv, it's given. How will you proceed for this question? Initial temperature is given to you, initial pressure is given to you, final pressure is given to you. You have to find final temperature. Everybody knows the answer now. Compression is adiabatic. So if you apply the adiabatic compression, you will get the result. So you see, for adiabatic compression we have equation is PV gamma is constant. Now I need equation in terms of P and T, because here I have P and T, so I have to eliminate P. So I will use the ideal gas equation, that is PV is equals to nRT. If I use this, I will have V is equals to nRT by P. Are you getting? If I plug this value nRT by P in this equation, so we will have P nRT by P to the power gamma. This is equals to constant. Now this becomes P to the power gamma minus gamma, so this is P1 minus gamma, and this n is constant, r is constant, so this simply T to the power gamma is constant. I can also write in a better way P T to the power gamma 1 minus gamma, this is equals to constant. Are you getting or not? I think you are getting. So this is the equation. Either you use this equation or you can use this equation. Anyone you can use. So you see, so let us, if I use this equation, initial pressure is P0, initial temperature is T0 raised to the power gamma divided by 1 minus gamma. Final pressure you have to find it out, this is eta P0, and we have to find final temperature, that is gamma to the power T to the power 1 by 1 gamma by 1 minus gamma. So P0 goes. So we will have simply this P0 cancels out, so we will have T0 raised to the power gamma divided by 1 minus gamma divided by eta is equals to T to the power gamma 1 minus gamma. Now if you want to write T, so you have to take root this side, so it will be simply T0 divided by eta 1 minus gamma divided by gamma. Are you getting? If somebody wants, you can also write this is T is simply T0 eta to the power, so this goes up, so it will be minus gamma minus 1 by gamma. You check yourself, the mathematics is simple in this case. Now B part of the question says find out the work performed on the gas. So we have to also find work performed on the gas. So B part, work performed on gas. Now see, the process is basically adiabatic compression. So in case of adiabatic process, dq is 0. So du is equals to du plus dw, this is equals to 0 if I apply first law of thermodynamics. So dw is nothing but minus du, and expression for du is NCV dt, so this becomes minus NCV dt. So number of moles, so dW will be minus N, and Cv is R by gamma minus 1, are getting, and dt is T2 minus T1. Now this is Nr by gamma minus 1. T2 I have already calculated. You see in the last page, T2 is T0 eta to the power gamma minus 1 by gamma, are getting. So if I plug the value of T2, you will have T0 eta to the power gamma minus 1 by gamma, but T1 is T0, initial temperature was T0. So if you take T0 common, so you will have Nr T0 gamma minus 1, and now here you will have, let us say, minus sign if you absorb, so this will be 1 minus eta to the power gamma minus 1 divided by gamma. So this is the work performed in this process. Now if you see, this will be the work done by the gas, because in physics what we see, dW is the sign dW means, so dq is equals to du plus dW. dW has been taken work done by the gas, so work done on the gas basically. So this is work done by the system. So in physics basically, work done by the gas. So this equation, this gives you work done by the gas, that is nRT by gamma minus 1 divided by 1 minus eta gamma minus 1 by gamma. If I want to find work done on the gas, I have to take a negative sign of this. So work done on the gas will be work done on the gas. And now this will be with a minus sign. So let us say minus, if I take minus and I absorb minus inside the bracket, so this will be eta to the power gamma minus 1 by gamma minus 1. So this is the performed on the gas during the compression process. So this is a very easy problem. You see what we have learned in this problem is, the adiabatic equation is given by basically PV gamma is equals to constant. So this equation I can write in terms of PV, I can write in terms of TV, I can write in terms of variable PT. So these are the possible variable, and to change in these variable, this equation in PV variable, if I want to change into T and V variable or P and T variable, I can use PV is equals to nRT equation. So if you use PV equals to nRT, you can change in any two variable. That's the first important point we have in this question. Another important point, in first law of thermodynamics, this is dq is equals to du plus w. In this equation, this dw is basically work done by the gas. So this is work done by the gas. So if I want to find out work done on the gas, I have to take the negative sign of the result that is coming out from the mathematical calculation. I think all of you are able to see this one. So anything if I missed from the top, you can copy fast, and then I can go for the next problem. So in case of adiabatic process, finding work done is very easy. Simply this is minus NCV dt. Everybody knows in adiabatic process dq is 0. We'll discuss the next problem.